Some of the most widely used types of data that you encounter in machine learning process are numbers, text, and image. And it turns out that the feature engineering process is applied differently depending on this type of data incarnation that you are working with. The numerical data usually comes in a tabular format, and it is subject to, let's call them, classical feature engineering tasks. And just to do a quick recap of these tasks, let's remember about aggregation, about part of, about binning, about flagging, about frequency-based calculations. There are also some more advanced feature engineering tasks that can use embedding or feature learning, as we call it, and deriving by example. Text is, by its nature, not really suitable for numerical processing. Hence, there is a need to translate text into a numerical format that can be used and is accepted by the various machine learning algorithms. Text embedding is the process through which sequences of words, or if you think about it, really natural language, are transformed into numerical formats, which are usually appear as vectors, as numerical vectors. There are several approaches that are common for text embedding, like text frequency, inverse document frequency, and word embedding. But don't worry, we will discuss these techniques in much more detail later in the course. Finally, image has pretty much the same problem as text. The RGB format, or any other equivalent formats for that matter, are not really suitable for machine learning algorithms, so they need to be translated. And to help you understand this, think about an image in its simplest form as a matrix of tuples of three values: the red, the green, and the blue channel. So say you have a 500 by 400 pixels image, and each of those pixels in the image contains the three values. So this means that you actually have 20,000 values times 3, which amounts to 60,000 numerical values, which is basically the numerical representation of your image. And this numerical representation can take a variety of forms, ranging from a simple vector of 60,000 values all the way up to complex matrices, like, for example, a 500 by 400 by 3 multidimensional matrix. In most cases, feature engineering is not really required before the training process for images, especially when they are fed into neural networks, because this process of feature engineering kind of happens naturally within the hidden layers of the neural network. In fact, specialized cases of neural networks, like, for example, convolutional layers or max Pauling layers, actually are dedicated to learn those features, and hence they are capable of learning increasingly complex patterns within your image data.